Okay, we are back looking at another one of the problems from the Linear Equations, Systems, and Inequalities problem set. And this time we are looking at question number 30, which I think is a great one to go over because we had a ton of questions about this one in class today. And this is the last question in the problem set. It talks about a solution to a system of inequalities. So the very first thing that we should notice looking at this one is that we are not dealing with a system of equations. We're instead dealing with a system of inequalities. I noticed that the second inequality is already in slope-intercept form. I'm going to refer to this one as the blue inequality, and the one just above it, the first one, I'm going to refer to this one as the red inequality. It is not in slope-intercept form. However, what I'm going to do off to the side is take a moment to go ahead and rewrite this one in slope-intercept form. And to do this, I'm going to notice that each of the terms in this inequality is divisible by 2. I've got a coefficient of 2 in front of the y, a coefficient of negative 12 in front of the x, and a constant term of 4. So absolutely everything can be divided by 2. Let's go ahead and do that. And I end up with y is less than negative 6x plus 2. And this one looks very, very similar to the blue inequality, which is the second one. And you'll notice that the only difference between them is that the y-intercept is different, but the slope is the same. So what I think we should do from here is go ahead and graph this in Desmos so that we can see what this system looks like. Okay, I went ahead and graphed these in Desmos so that we can take a look at them. Starting with the first one, this was the red inequality, and this was the one that we changed to slope-intercept form. Notice we have a dashed boundary line, so take care, all of our solutions have to be values that are below or less than that boundary line. Next, we have the blue inequality, which has the same slope but a different y-intercept, a positive 4 y-intercept. When I graph them both simultaneously, we have a region where both inequalities have a solution zone of overlap. And if we look at this particular zone, we'll say it's purple. And this shows us that this is a solution to both the red inequality and the blue inequality simultaneously. So what we want to do is go through and look at our answer choices and see where are these ordered pairs and could they potentially be a valid solution. Okay, so using Desmos, I went ahead and plotted the ordered pairs for each of the answer choices, for choices 1, 2, 3, and 4. And we can see those plotted right here against the system of inequalities. So noticing first, answer choice number 1 and 2, neither of those answer choices are actually in the overlapping region, nor are they actually a solution to either of the inequalities individually. So they definitely cannot be considered correct. Then looking at choice number 3, which is a little bit more interesting, notice that choice 3 actually sits on the boundary line for the red inequality, and it is part of the overlapping region for the blue inequality. So it might be tempting to think of this as a possible answer choice. However, since that is a dashed line, this means that it is a less than value. No values that actually sit on the boundary line can be considered a solution. And that leads us to answer choice number 4, which is very clearly part of the solution set. It sits very comfortably in the purple region, and it is definitely the best answer for this particular question. So going back to our answer choices, we decided that answer choice number 1 is definitely not going to work, neither is 2. Answer choice 3, unfortunately, is only a solution to one of the inequalities, the blue one. And then answer choice number 4 sits in that purple region very comfortably, and that is our solution to our system of inequalities.